Hello everyone, today we will present about Electronic Systems Assignment Uni-junction Transistor, UJT. This is our group members. Introduction.
Assalamualaikum and hi, my name is SUHAILLAH binti Muhammad Sulaiman. My matrix number is B0822108180 and I am from 3BET 3/1. Together with my team, we are going to present about Uni-junction Transistor. I will start to present about introduction of Uni-junction Transistor. The Uni-junction Transistor UJT is a semiconductor three-terminal device with negative resistance and switching characteristic for relaxation oscillator in phase control application. Uni-junction Transistor UJT is another solid-state three-terminal device used in a gate pulse timing circuit and trigger generator applications for switching and control of either transistors or triacs for AC power control type applications. Just like diodes, a uni-junction transistor is made from separate P-type and N-type semiconductor materials, forming a single PN junction within the main conducting N-type channel of a UJT device. Although the UJT has the same name as a transistor, it has very different switching characteristics from a conventional bipolar transistor or field effect transistor because it cannot amplify a signal, but instead is use of an on-off switching transistor. UJTs have a one-way conductance and negative impedance characteristic, acting more as a variable voltage divider during breakdown. The UJT is made of one solid piece of N semiconductor material, forming the main current carrying channel with two outer connections labeled base 2B and base 1B. The third connection, confusingly called the emitter E, is along the channel. An arrow pointing from the P-type emitter to N-type base designates the emitter terminal. The P-type material is fused into the N-type silicon channel to form the uni-junction transistor emitter, rectifying PN junction. Though they are less common, P-channel UJT with an N-type emitter terminal also available. In order to be closer to terminal B2 than B1, the emitter junction is positioned along the channel. The UJT sign uses an arrow that points in the direction of the base to show that silicon bar is negative material and the emitter terminal is positive. The UJT's layout is shown in the slide. Thank you, that's all from me.
Operation of Uni-junction Transistor.
Assalamualaikum and hi, my name is Fizuan bin Muhammad NIZAM. My number matrix is B08221462. My class is 3BERT section 3/1. For today, I will explain about operation of uni-junction transistor. As you can see, in figure 3.0.1 shows the operation UJT under Roman 1 VE equal to 0 and Roman 2 applied volt. So, we assume that there is no voltage applied to the emitter supply. The emitter diode is then reverse biased by the inherent standoff voltage, as previously indicated. If the emitter diode's barrier voltage is VB, then the total reverse bias voltage is equal to VA plus VB equals to efficiency VBB plus VB. In silicon, VB is equal to 0.7. Let's now gradually raise the emitter supply voltage VE. IEO will be lowered to 0 when VE equals efficiency VDB. Neither forward currents nor reverse current will flow when the voltage levels on either side of the diode are equal. So, for the net parts of operation of uni-junction transistor, we have figure 3.0.2 that show equivalent circuit of UJT. The UJT uni-junction transistor become forward biased when the emitter supply voltage exceeds the total reverse bias voltage. This triggers emitter current flow. Starting at the peak point voltage Vp, as Vp increases, more charge carriers are introduced, decreasing resistance in the Vp region. This intensify forward bias lead to a large current. Limited by the emitter power supply, the UJT exhibits a negative resistance characteristic, with Vp decreasing as emitter current rises. Base 2 B2 is activated by an external voltage VBB, and the UJT is turned on by a positive pulse on the emitter and off by a negative trigger pulse. That's all from me. Thank you.
Characteristics and performance of Uni-junction Transistor, UJT.
Assalamualaikum warahmatullahi wabarakatuh. My name is AFIQAH SAHIRA. So for the characteristic of Uni-junction Transistor, figure depicts a UJT static emitter characteristic, which is a curve that illustrates the relationship between emitter voltage and emitter current at a specific interbase voltage. Figure shows that the emitter current need exceed IE0 for emitter potential to the left of peak point. The reverse leakage current IC0 of the standard UJT and the current IE0 match remarkably well. The cut-off region is this area, as seen in the illustration. The emitter potential decreases as the emitter current increases once conduction is established at Be equal to Vp. This is precisely in line with the drop in resistance that occurs when current increases. As seen in figure, the device eventually enters the saturation region when the valley point is reached, and any additional rise in the emitter current cause it to do so. IP, BB and IV are three other crucial UJT factors. So first, for the IP is peak point emitter current. At the peak, it is the emitter current. It stands for the lowest current necessary to activate the gadget. Its relationship to the enter-base voltage is inversely proportional. Second is VV, which is valley point voltage. The emitter voltage at the valley point is known as the valley point voltage. As the interbase voltage rises, so does the valley voltage. So for the last one is IV. IV is valley point current. The emitter current at the valley point is known as the valley point current. It rises in tandem with the VBB interbase voltage. That's all from me. Thank you.
Application of Uni-junction Transistor, UJT.
Hello, my name is MOHD. I will explain about application of Uni-junction Transistor UJT. So, before we dive into relation oscillator, let's understand the broader context of oscillator. Oscillators are circuits that generate periodic waveforms. Today, we are confused and a specific type of relation oscillator. So, what actually is a relation oscillator? Simple put, it is a circuit that produces a non-sinusoidal waveform after a square wave through the periodic charging and discharging of a capacitor. Let's explore how it works. At the core of relation oscillator is the interplay between charging and discharging circle of a capacitor. The transition are triggered by a threshold voltage, and the circuit typically involves components like resistor, capacitor and switching element such as junction transistor or operation amplifier. Now, where relation oscillator find their application? They are commonly used for pulse generate timing and clock generate in digital system, and even in frequency synthesis for communication system. In conclusion, relaxation oscillator play a vital role in generating periodic waveform, contributing to various electronic systems. Their simplicity, versatility and robustness make them indispensable in the world of electronics. Next, pulse generator in simple terms is a device designed to produce electrical pulse or waveform with specific characteristics providing precise timing in various electronic applications. There are several types of pulse generators serving unique purpose. We have monostable multivators which generate a single pulse in response to an external trigger. Then the stable multivators produce a continuous stream of pulse without internal triggering, and of course program pulse generator providing user with the flexibility to adjust pulse parameter. Working principle is depending on the type. Pulse generator typically involve components like resistor, capacitor and switching element. The choosing configuration determine how pulse are generated and their specific characteristics.
Hi, my name is ARIQAH. So for voltage regulator is a device that ensures a constant output voltage despite variation in input voltage or changes in load conditions. In simple terms, it keeps our electronic device running smoothly. Voltage regulators are ubiquitous. You find them in power supplies for electronic devices, stabilizing voltage in automotive systems and ensuring consistent power in portable electronics. Their role is fundamental to the reliability of our gadgets. The advantages of voltage regulator are clear. Stable voltage output, improved reliability by safeguarding against fluctuations and enhanced energy efficiency. These benefits make voltage regulator an essential component in the world of electronics. Alright, so lastly for voltage regulator, it plays a critical role in the stability and reliability of electronic system, whether in our smartphone, cars or household appliances. Their presence ensures smooth operation and protects our device from voltage fluctuations.
Conclusion.
So for the conclusion, the Uni-junction transistor is a versatile semiconductor device with unique characteristics such as negative resistance and relaxation oscillation, making it suitable for signal generator, timing circuit, and pulse generator. However, UJT have specific operating requirements and limitations, making them valuable components in electronic design for specific circuit functionalities. That's all from us. Thank you.
Thank you.